Welcome to the Bare Metal Cyber CISSP Prepcast. This series helps you prepare for the ISS Squared CISSP exam with focused explanations and practical context. In this episode, we are going to examine an often overlooked but critically important area of cybersecurity testing: security test data and environment management. These two elements are foundational for conducting secure, realistic, and effective testing across your organization's systems and applications. As cybersecurity professionals, we spend a lot of time focusing on security controls and vulnerabilities, but the way we manage the data used in tests and the environments where those tests occur can dramatically influence the accuracy and safety of our testing processes. Done properly, security tests data and environment management not only improves detection of vulnerabilities, but also minimizes the risks of data leaks, operational disruption, and compliance failures. Let us begin by understanding what security test data management actually means. When security professionals or developers test systems, they need datasets that resemble real-world data to produce meaningful results. These datasets are used to evaluate how applications behave, how well security measures perform, and whether controls are detecting and preventing the kinds of threats they are designed to stop. But using real production data during testing can create serious risks. That is why organizations must carefully manage what test data is used and how it is handled. Security test data refers to any data set created or used during testing of security controls, applications, or systems. This data must be realistic enough to simulate actual use cases, but must not include sensitive or confidential information. Effective test data management ensures that testing scenarios mirror real-world conditions while protecting sensitive data from exposure. This includes personally identifiable information, financial data, internal business information, or anything else that could lead to privacy violations or organizational harm if leaked. When managed correctly, security test data enables more accurate vulnerability detection, security validation, and compliance testing. For example, if a tester wants to evaluate how an application handles various user roles, the test data must include realistic representations of users, permissions, and workflows. If the data is too simple or unrealistic, the test might miss critical issues that only occur under specific conditions. By understanding and applying good test data management practices, organizations improve both the effectiveness and safety of their security testing processes. Now let us talk about how to create secure and effective test data. The goal is to generate data that behaves like real production data but does not carry the same level of risk. One common approach is to use synthetic data. This involves generating fake data that mimics the structure, format, and relationships of real data. For example, synthetic names, email addresses, or transaction histories can be created to test an application without using real customer information. Another approach is anonymization, where identifying information is removed or scrambled so that individual data subjects cannot be identified. Related to this is data masking, which involves obscuring sensitive parts of the data, like replacing credit card numbers with randomized values, while still preserving the format and logic of the data for testing purposes. These techniques help protect confidentiality while maintaining testing accuracy. It is also important to update and refresh test data regularly. As systems evolve and business processes change, old test data may no longer represent current workflows or configurations. Outdated data can lead to misleading test results or overlooked vulnerabilities. Organizations should review test data periodically and update it to reflect the latest application features, security controls, and threat scenarios. To be effective, test data must also be validated. This means checking that the data is accurate, consistent, and appropriate for the specific testing objectives. For example, if you are testing for input validation errors, the test data should include edge cases, malformed inputs, and unexpected characters to reveal weaknesses in how the application handles input. When managed properly, test data becomes a powerful tool that supports accurate, meaningful testing without putting sensitive information at risk. Next, we turn to the environments where testing occurs. A security test environment is a dedicated system setup that replicates production conditions but is isolated and controlled. The purpose of a test environment is to allow safe, comprehensive security testing without interfering with live systems or real user data. Test environments enable security professionals to simulate attacks, run vulnerability scans, and validate security controls under realistic conditions. Properly managing test environments begins with configuration. The environment must accurately reflect the production setup, including the same versions of software, the same access permissions, and the same network architecture. If the test environment does not match production, results may be misleading. For instance, a vulnerability might go undetected in testing because the environment lacks the same firewall rules or authentication settings used in production. Test environments should also be isolated from production systems. This means ensuring that there are no shared data stores, network paths, or user accounts between the test and production environments. Isolation helps prevent accidental data leaks, unauthorized access, or performance disruptions during testing. A common best practice is to set up secure network segmentation and dedicated access controls to ensure that tests cannot interfere with live services. Effective test environment management includes controls over who can access the environment, what tools and scripts are used, and how test results are stored and reviewed. With careful design and oversight, a security test environment becomes a safe and reliable space for performing robust security evaluations without risking production stability. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Let us now explore how to implement effective data and environment management practices. It starts with documentation. Organizations should clearly document policies and procedures for creating, handling, storing, and disposing of security test data. This includes specifying who is responsible for managing the data, what tools may be used to generate or mask it, and how data is to be retained or destroyed after testing. Next, test environments must be securely configured and maintained. This involves establishing dedicated infrastructure, restricting access through role-based controls, and applying security patches regularly. Ideally, these environments should be provisioned automatically through scripts or infrastructure as code, ensuring consistency and reducing configuration drift. Automation can also help streamline test data creation. Tools that perform automated data masking, anonymization, or synthetic generation can save time and reduce errors. These tools can be integrated into the testing workflow, allowing data to be prepared automatically whenever a new test environment is spun up. Auditing is another critical element. Regular audits of test environments and test data help ensure that they are secure, compliant, and aligned with current standards. This might include checking for unauthorized access, validating encryption settings, or confirming that outdated data has been removed. Auditing reinforces accountability and helps identify gaps in the process. Training is equally important. All personnel involved in testing, whether developers, testers, administrators, or security analysts, must understand the importance of secure data and environment management. They should know how to create safe test data, follow isolation procedures, and report any deviations or concerns. Strong security controls are required to protect both the data and the environment. Sensitive test data must be encrypted during storage and transmission. Even synthetic or masked data should be protected if it could reveal system behavior or business logic. Test environments should be secured with multi-factor authentication, role-based access control, and endpoint protection. Monitoring and logging solutions should be in place to detect unauthorized access or unusual activity. These logs should be reviewed regularly as part of an overall monitoring strategy. Vulnerability assessments and penetration testing should be performed on the test environment itself. Just because it is not a production system does not mean it is immune to threats. A compromised test environment can still be used to launch attacks, steal data, or disrupt development. Organizations should ensure that backup procedures are in place for test data and that all sensitive data is securely deleted after use. Continuous improvement is the final piece of the puzzle. Security test data and environment management should not be static. Policies, tools, and processes must evolve alongside technology and threats. Organizations should conduct regular reviews of their practices, using input from incident reports, audit findings, and security assessments to refine their approach. Cross-functional collaboration is essential. Developers, testers, system administrators, compliance officers, and security teams must all work together to maintain secure testing practices. No single team can manage this process alone. Everyone has a role to play in protecting data and ensuring that testing is both effective and secure. Training must be ongoing. As new threats emerge and new tools are introduced, staff need up-to-date knowledge to do their jobs effectively. Organizations that invest in training and awareness programs will be better prepared to adapt and maintain a strong security posture. Thank you for tuning in to the CISSP Prepcast by Bare Metal Cyber. Visit baremetalcyber.com for additional episodes, comprehensive CISSP study resources, and personalized certification support. Strengthen your understanding of security test data and environment management, and will consistently support your journey towards CISSP certification success.